Hello everyone and welcome to today's Flare Builder online workshop. My name is Nick, I'm a DevRel at Flare, and today's workshop is titled From XRPL Control to Flare, Yield Means and Vault Deposits with Smart Accounts. This is in fact the second workshop on Flare Smart Accounts, and specifically about a few example scripts that you have prepared about how you can mint FXRP to an arbitrary Flare account, how you can mint and deposit FXRP into one of the vaults with a single instruction, and how to look at the smart accounts state. So, in this workshop, we'll first of all have a quick look at what Flare Smart Accounts are. We'll then also look at the encoding of smart accounts instructions, but only very briefly and only in regards to three instructions that are related to what we'll do afterwards, and that's we'll look at three example scripts. So the first script will show us how we can mint and transfer FXRP using smart accounts, and this is basically equivalent to minting FXRP to a random, or not a random, an arbitrary Flare address. Then we'll also look at the script for looking up the smart account state. And lastly, we'll look at the mint and deposit script, which basically mints FXRP and deposits it into an Upshift type vault. There will be time for a Q&A at the end. So if you have any questions during the workshop, do post them in the chat, and I'll look at them at the end. So yeah, first of all, the Flare smart accounts. As I've mentioned, this is the second workshop about Flare smart accounts. If you want a more in-depth explanation of the smart accounts, go watch the Flare Builder online workshop session 15. You can find it on YouTube in the or under the live tab. So right here. But anyway, what is Flare Smart Accounts? Flare Smart Accounts is an account abstraction schema which gives the XRP users, XRPL users, access to the Flare ecosystem. How they work is each XRPL address gets assigned a so-called personal account contract on the Flare chain. A list of all the personal account contract, or rather the mapper from XRPL addresses to the personal account contracts is stored by the master account controller contract. So this XRPL address to which the personal account belongs is the only address that can control it. And so the personal account acts as a normal EVM account. But it again can only be controlled by the XRPL account it belongs to. So the XRPL user, when they want to do something on Flare, they signal their intent by sending a payment transaction to the operator address with the instruction encoded and attached to that. and then the personal account actually executes that instruction. More happens between those two steps, but I'll cover that in just a second. Before that, let me explain why the smart accounts are useful, or at least two use cases for the Flare smart accounts. The first one is that the smart accounts allow XRPL users to interact with the Flare chain, to take part in the Flare ecosystem without knowing anything about EVM chains, without having a wallet, without holding any Flare. So all of that through the XRPL alone. But there's also another use case, and that's meant for the EVM chain developers, and that's simplifying the minting process. Because if you remember anything about the F-assets minting, you know that there's a lot of steps involved, and the Flare smart accounts allow you to kind of sidestep a lot of that, and reduce it to basically sending two XRPL transactions, which is quite neat. If you want to know more about F-assets, I do urge you to go check out the Flare Developer Hub and the F-assets section of that. And as I've mentioned, if you want to see another video about the Flare smart accounts, go watch the Flare Builder online workshop session 15. But yeah, with that, let us look at the F-assets workflow. So this diagram shows us how the F-assets workflow goes. We first of all start with an XRPL user, and they want to perform some action on the Flare chain. First of all, they signal their intent by sending a payment transaction to the operator, to one of the operator addresses on XRPL. So they send the payment with the encoded instruction attached as the memo of the payment transaction. And then we have the operator. The operator is a service run by Flare. It's a server that monitors incoming transactions into the to the operator addresses on the XRPL. And upon observing such a transaction, they basically bridge it to Flare. And they do so, or it does so, by first of all asking the FDC, which is one of the Flare protocols. And if you want to know more about FDC, we've made several videos about FDC here on YouTube. And there are also written guides on the Dev Hub. But anyways, the FDC proves the transaction, which is basically equivalent to bridging it onto the Flare chain. And once that is done, the operator takes the proof of that transaction and carries it to the master account controller contract. Now, the master account controller contract is like the central nervous system of the Flare smart accounts, because what the master account controller does is, first of all, it stores all the relevant information. So the master account controller defines the XRPL addresses that the operator monitors. It also stores a mapper from XRPL addresses to the addresses, to the Flare addresses of the personal accounts that belongs to them. So when the operator brings the proof of the payment instruction to the master account controller contract. That proof also includes the sender's address and the encoded instruction. So the master account controller checks its mapper to retrieve the personal account address that belongs to that XRPL address, and then decodes the instruction and delegates the execution of that instruction to the personal account. And then the personal account executes the instruction itself. So that's very, very briefly on how the Flare smart accounts work. Now, let's look at the encoding for the Flare smart accounts. And before we get into this, let me just say that we have prepared an npm library. So that is at Flare Network Smart Accounts Encoder that takes care of the encoding for you. So you don't really need to know the details of how an instruction is encoded to use it. But anyways, the three instructions instruction encodings that we'll look at today all correspond to example scripts that we'll see later. There are more. There are as of yet 11 different instructions, and you can read more about that on the Flare Developer Hub under the Flare Smart Accounts Facet Instructions tab. Here everything is explained in more detail. But let's look at these three right now. First of all, each instruction is 32 bytes long. All the first 2 bytes are the same shape for all of the instructions. So first of all, the second byte is the wallet identifier. And if you're normal developers, this will probably just be left as 0. But basically, this is a number that Flare assigns to you just so the operator can identify the incoming transactions or the sources where they come from. And that just for monitoring purposes to know if things are working as they should. Now, the first byte, that actually signals what, that is actually the instruction ID. And the instruction, and there are 11 different instruction and 11 different IDs as of yet. And the instruction ID tells you or tells the operator what kind of instruction this is. So each instruction ID is further broken down into 2 nibbles. So first 4 bits and the second 4 bits. And the first nibble, so the first 4 bits, they represent the instruction type ID. And the instruction types that are supported so far are FXRP, Firelight, and Upshift. So for FXRP, that's the hex representation of 0. For Firelight, it's 1, and for Upshift, it is 2. And then the second nibble is the actual command ID. The commands are all tied to the instruction type, but in this case, the collateral reservation command of the FXRP type has the ID 1, the transfer has 2, and the collateral reservation and deposit command of the Upshift type has the hex representation of 1. But theoretically, both of these nibbles could carry values from 0 to F, which is the hex representation of the number 15. Then, after the wallet ID, the remaining 30 bytes, these are different between different commands. So, in the case of collateral reservation, the FXRP collateral reservation, we get first the next 10 bytes are the number of lots of FXRP that we want to mint. Then there are 2 bytes for the agent vault ID, and the agent vault ID is a number. Basically, the master account controller contract stores a registry of registered vaults, which is basically a mapper from ID. Sorry, not a mapper. It's 2 arrays of the first array being the ID, and the second the corresponding agent vault address. And we'll actually see that when we run the state lookup script. And then the remaining 18 bytes are empty for this instruction. Then we have FXRP transfer, which for which the value field is again 10 bytes long, but in this case it is drops of FXRP that we want to transfer to the recipient flare address. So the last 20 bytes are the flare address that we want to transfer the FXRP to. So that's just standard EVM address without the 0x prepended to it. And then lastly, we have the Upshift collateral reservation and deposit. This one again has value as the third field. And this is again the number of lots of FXRP that we want to mint, and in this case also deposit into an Upshift type vault. We again have the agent vault ID, but then the new number is the vault ID. And now, just the same as with the agent vaults, the master account controller also stores a list or a registry of vaults, and in this case it is 3 arrays, the first being vault ID, the second the vault address on Flare, and the third one the vault type, because we store the Upshift and Firelight type vaults within the same registry. And yeah, we could hypothetically have multiple Upshift type vaults. For example, we could have vaults with different rates, with this different risk portfolio profiles, and so on. And a user is able to select what vault they want to deposit into. And the remaining 16 bytes are then again left empty. Okay, so with that, we can now look at the actual scripts. The scripts we have prepared are available on GitHub in the Flare Smart Accounts VM repository. What I have already done is I have cloned the repository and set up the .env file. Yeah, the example scripts here are written in TypeScript, which is probably very useful if you build a front end in React or something like that. The Yeah, as you can also see from the name of the repository, we are actually using VM to read the stuff from the Flare chain. But that is all that we are using VM for. The whole point of the Flare Smart accounts is that you don't need to write anything on the Flare chain. You only need to send XRPL transactions. And for that, we are using the XRPL library. So yeah, but we are reading the stuff from the Flare chain because there are certain stuff that we need to be able to see for the thing to work. Cool, cool, cool. Yeah, as I've said, and let's maybe clear the terminal. This is the Flare Smart Account VM repository. I have cloned it. I have set up the .env file. And now let's look at the scripts. So I'll run this before I start explaining what the script does, just so we have it ready or have it done by the time that we are done looking at the code. So I'll go to the terminal and write pnpm run script, and this is just a command that we have registered in the package.json. You can, of course, use any whatever your preferred package manager is to run this. Oh yeah, before you can run this, you also have to install the dependencies, but that's to be expected. Anyways, I'm gonna do pnpm run script source minting transfer dot typescript and let that run while we look at the actual file. Now we'll start our exploration of the code by looking at the main function because it's been written in the way that you can see what's going on by simply looking at the main file, main function itself. So first of all, we have the collateral reservation data. Oh, let me first of all explain what we are actually doing with this script. So we're gonna mint FXRP and transfer it to some predefined account on Flare. This is the recipient address. It's just one of the burner accounts that I use for testing. So in order to be able to mint FXRP, what we first need to do is reserve collateral with one of the agents and then actually transfer XRP to the agent's XRPL address. So these are two transactions that we need to perform on the Flare chain to mint FXRP. And then we also need to send the instruction for transferring FXRP from our personal account to the address that we have chosen. Anyways, the wallet ID is left at 0, as I've said. We will be minting one lot of FXRP with the agent that has the vault ID 1. Then we need to set up the the XRP wallet. That's just something that the XRPL library requires. in an actual React example, you would probably wrap the whole thing in a context with with the actual wallet. But anyways, first of all, we will need our personal account address to be able to monitor events to the FSH system. So first of all, we get that. Then next, we prepare the collateral reservation instruction. We do so using the library that I have showed you. We just import the FXRP collateral reservation instruction class, make a new instance with our data, and then we can call encode. Then we call encode on that instruction. I said that I'll answer the comments at the end, but I've just noticed one that is perhaps easy to answer, and the answer is no, actually, we do not need a Flare wallet to do this. We only need an XRPL address that will allow us to send the instructions on XRPL, and the whole reading of the Flare chain is done without the need of a Flare wallet or a Flare account. Anyways, we prepare the instruction, we can encode it by just calling encode, and then we remove the first two characters, which are 0x. And then we reserve collateral. What this does, we'll look at what this means in a second. Once we have reserved the collateral, we get the necessary information that we need to make the mint payment, and so we also send the mint payment, and then we need to wait for some more for the minting to be executed before finally we can send the transfer instruction. And for the transfer instruction, again, wallet ID will be 0. We will send a lot worth of FXRP, which is 10 FXRP, and we also need to use the decimals or get the decimals of FXRP so that we are actually transferring whole units of FXRP, and we can get the decimals with another helper function. And yeah, we again encode the instruction using the encoder library. Then we just log balances so that we will be able to see that things have changed. And finally, we execute the transfer. We can send the transfer instruction, wait some more, and then log balances once the transfer has happened. Now, let's look at the functions we've seen in more detail. So first of all, get personal account address. What this function does is it uses the VM read contract function to go to the master account controller address. This is the master account controller contract on Flare, and it calls its get personal account function with the XRPL address parameter, and this is the address that we are giving. This is our address. How are we reading the XRPL address? I have put my XRPL seed, the secret number, into the .env file, which in production you wouldn't want to do, but since it's just a burner account for testing, we don't really care. Anyways, This is how we get the personal account address. And then we need to reserve the collateral. So in order to reserve the collateral, we send an XRPL payment to the operator XRPL address, paying the necessary instruction fee and giving the encoded instruction as the memo of the transaction that we are making. How do we get the operator XRPL address? Again, we read the master account controller contract using VM. This time, get XRPL provider wallets. And just for the sake of simplicity, we take the first element of that array, though in theory we could use some other wallet address. For the instruction fee, it's the same deal. Again, we read the master account controller contract. This time the get instruction fee function, and as argument, we input the first byte of the instruction. So yeah, the actual instruction ID. This is what determines the fee, and we return the number. Am I forgetting anything? I don't think so. We don't need this comment. Anyways, we sent the XRPL payment, and then we need to watch for the collateral reserved event to be emitted. The collateral reserved event is actually emitted in two places: by the master account controller contract and by the FXRP asset manager contract. And this is the one we are interested in now, because this one is actually directly part of the FSS system and carries the necessary information to make the next transaction that we need to make. So first of all, how do we get the address of the asset manager FXRP? Well, we call the get contract address by name function on the Flare contract registry. This is just a contract on Flare that stores a registry of the official Flare contracts. And we call this function with the name of the contract that we want, in this case, asset manager FXRP. And with that, we can watch for the collateral reserved events coming from the asset FXRP asset manager. And we do so by just running a loop that goes on until an event has been found. And here you can see that the event also needs to be a proper event, in the sense that so the personal account is the minter, the one that initiating the minting process, so we don't accidentally make a payment for someone else. And yeah, when we get that event, we just return it. So yeah, we get the collateral reserved event, then we can send the mint payment. So from the collateral reservation event, we get the value and the fee that we need to pay. So the amount that we need to send in the mint payment is actually the sum of these two values. We get the payment address to which we need to send the mint transaction on XRPL, and the payment reference we need to attach as memo. And then it's just as simple as send an XRPL payment to the payment address with the sum of the values and the payment reference attached. And after that, we wait for the minting executed event again on the asset manager, FXRP asset manager contract. And we also check that the collateral reservation ID matches our collateral reservation ID. And that when that happens, we return the event. Now, for the decimals, we actually need to read the FXRP contract. This is the token contract of the FXRP token. And we call its decimals function, which returns 6. Because that's the number of decimals. And then lastly, we make the transfer payment. And this again takes the encoded instruction, puts it in the memo, gets the instruction fee from the master account controller contract, gets the operator address from the master account controller contract, and makes a payment transaction to that address, and then just waits for the FXRP transferred event on the master account controller contract. And when we see that event, we will know that the value has been transferred. Let's look at the actual execution of the script now. First of all, we can see the personal account address is this one. This is the encoded collateral reservation instruction. The fee is 0.001 FXRP. And then this is the transaction hash of the transaction that we have sent the instruction in. We could go look at the FXRP Explorer, XRPL Explorer to get to see the transaction if we had more time, but there's no value in that really. When everything works, I mean, you only need to look at that when things go wrong. Anyways, if this was, if we were still waiting, it would just say waiting for collateral reservation and nothing else. But once the event is found, it gets printed to the console, and we can see this is the agent vault, this is the minter collateral reservation ID. This is equals to 10 FXRP or 1 lot, and this is the fee, or the fee is 0.025 FXRP or XRP, sorry. And this is the payment address to which we need to send the mint payment and the payment reference. And as we can see, the minter is in fact the same as our personal account. So this is the correct event. This is some data repeated again. Anyways, we make a mint transaction. It has this hash here. And then we see that the minting has been executed. So we can proceed. 6 is the number of decimals. Then the transfer instruction, once it's encoded, it looks like this. And now let's look at the actual balance. So this is the balance on our personal account before we make a transfer, and this is the balance of on the recipient side. We have 220 FXRP. The recipient address has 40. Then we send the the transfer instruction. We notice we observe the event, and afterwards we have 210 FXRP but more importantly, the recipient address now has 50 FXRP instead of just 40. So this is basically how you can mint. This is how you can mint FXRP to an arbitrary Flare address. Now, the state lookup function, state lookup script. Let's run that, and this one will execute much faster because it's just reading state data from the chain. This is how you can get the XRPL address, our personal account address, the FXRP balance, but more interestingly, the vaults that are registered with the master account controller contract. We can see we have two vaults, vault 1 and 2 with these addresses. The first one is type 1 vault, which is a Firelight type vault, and the second one is type 2 or an Upshift type vault. And then we are also printing the FXRP balance for our personal account in each of these vaults. And finally, the agent vaults are currently just this one. I'm noticing now that I could have displayed the whole array of XRPL addresses for the operator wallets, and that is going to change in the future. Anyways, let's look at the state lookup function. First of all, we've already seen how we get the operator XRPL address. Then the personal account address is the same thing. FXRP balance, that's just calling the FXRP, the balance of function of the FXRP token contract with our personal account address. So nothing special there. Get votes. This function reads the master account controller contract and specifically calls its get votes function, and then it shifts around the data so that we get an array of vault objects instead of 3 arrays. And similarly, get agent vaults does the same thing, but for agent vaults. Again, with the master account controller contract. And then the get vault balance, what that does is looks at the vault contract and calls its balance of function. So all in all, not that complicated. It's basically just reading the right contracts, but that's where the complexity lies, knowing what contracts to read. And now lastly, let's run the Upshift mint and deposit script and also look at the code for that. This one is much simpler. It's designed that way. What this script does is what this script does is it sends the Upshift collateral reservation and deposit instruction on the XRPL. And once that instruction is sent, it also needs to send a mint transaction, and that's it. Then everything else happens in the background. So again, get personal account. We encode the instruction using the smart accounts encoder library. We send the instruction, which again is just making an XRPL payment to the operator address with the fee and the instruction added, the encoded instruction added as the memo, and then watching the collateral reserved events just the same way as we did with the mint and transfer. And once we find the event, we also send the mint payment. This is actually the same as in the mint and transfer. And then we just watch for the deposit event, and we log balances before and after that. So as you can see, this is our personal account address again. Our FXRP balance, the amounts that we have in each vault, the encoded collection reservation, deposit instruction, collection reservation transaction hash. And now we are just waiting, or sorry, we have waited for collection reserved event, send the mint payment. Now we are waiting for minting executed. While that is running, let me look at the slides once more because we are nearing the end of this workshop. These are again links to useful resources, so our DevHub, Twitter, and Discord, if you want to grab that. But otherwise, we'll jump into Q&A very shortly, and I'll break from the Q&A to just look at the result once that is finished. But what I really wanted to show you is the QR code for the quiz about today's workshop, which can qualify you to win a full set of Flare merch. So do grab that. Let's see if this has finished. Not yet. I'll take a sip of water and then I'll look at the questions. Anyone know when Zaman is ready to launch smart accounts? I think that Zaman is the best. They are the best person to or organization to ask about that. But when they are ready, they will announce it. I've already answered that, but just to repeat, we do not need a Flare wallet to interact with the Flare smart accounts. This is in fact what they were designed for, alleviating the need to have a Flare account. If we want to call the function of a DeFi application contract, can you show us how can we encode that call data so that we can get it signed by the Flare smart account rather than external wallet? Okay, this is a very interesting question. And there will probably be another workshop that will focus on this thing specifically sometime in the future. What you need to do is basically send a custom instruction. This one won't be part of the first smart accounts that get that become live on the mainnet. So this won't be a feature to start with, but we are already implementing it on the testnet. So it should soon be available on the testnet. Very briefly, what you would have to do is you would have to register a custom instruction with the master account controller contract for each function call that you want to make. and then the master controller would give you back the hash with which it stores the custom instruction in a mapper, and you would give that hash to the XRPL user to send in the memo field. Now you can look at the Flare Developer Hub and specifically, no, sorry, I'm lying. We have removed that guide since the Flare Smart accounts have gone through a lift up, let's say, and the previous version of the custom instruction has been deprecated, but it should be coming shortly. And when the smart accounts are available, and they should be available in the next 2 weeks if everything goes to plan. Once they are available, we also publish a guide on the Dev Hub explaining how to work with custom instructions, and we'll probably also make another workshop that will focus on custom instructions specifically. How will these smart accounts leverage the FLR token? So that's what the FLR token. So everything that happens on Flare operates through the Flare token. It's just a way for paying for gas. The smart accounts, what they do is to get rid of the need for the Flare token. They offset that by basically the fee, the instruction fee that needs to be sent with the instruction covers the Flare token costs, which are paid by the operator on the Flare chain for gas. So underneath it all is still the Flare token. It's just that instead of the XRPL user needing to have the Flare token and then actually interacting with the smart accounts, that gets covered by the fees, so they don't have to go through the exchange and the cumbersome process that is FSets to make it work. So yeah, but yeah, underneath it all is still the Flare token. Okay, there are more questions, but let's look at the results now that they have come in. So the vote balances before were just a bunch of nines, which is what we don't care. We have deposited into vault number 2, so that's the interesting part. The vault number 2 has, and let's see if I see this correctly. That's it has 49 FXRP, and then we execute the instruction, and afterwards the vault balance is 55 FXRP. So we see that we have successfully deposited FXRP into the Upshift vault with ID 2. Okay, cool. Another question. Oh, that wasn't a question, it's just a comment. Someone has commented that they are making an SDK for developers, which will greatly help based on this. We'll wait a few more minutes. If you guys think of any more questions, maybe another more minute, and then we'll end this workshop. But yeah, stay tuned for the upcoming or the upcoming workshop on the custom instructions uh, that will um, that we'll be hosting sometime in the future, and the custom instructions guides that we'll be posting. Well, since I'm not seeing any more questions coming in, or well, there's another one. Let's answer that one. What are some tools you would like to see built on the Flare network? Ooh, that's an interesting question. Hmm. I don't know. Maybe like plugins that help uh, with either smart accounts or FDC, something like that. Um, I don't know. I mean, the problem is I kind of offload this, or not offload, but um, I'm stuck in thinking of what our team can do for the ecosystem, not so much what others can build. So that's why I'm struggling with this question. Um, but yeah, anything that can simplify this process would probably be very, very useful. Cool. That's very good to hear. Well, anyways, it this concludes today's workshop. Stay tuned for more Flare content. Um, and thanks for joining us. Goodbye.